Okay, so previously I had one shift register hooked up to 8 LED lights, and I used a series of 3 different buttons to explain kind of how it worked and how they transferred the data into these LED lights, how they communicate with each other. And anyways, I had it so the green light was representing the data, and the blue light was representing recording the data, and the yellow light was representing inputting the data or outputting the data to the LED lights. And I did a demonstration with using those 3 different lights or inputs to record data, to output one at a time, to output all of them at a time, whatever. Here I have hooked them up, and with a second shift register, so additional LEDs, with the data line going into the first shift register, but the 9th output is the output for this shift register to output data into the next shift register. However, the blue line, which is recording what is on the data line, is hooked into the same line as the data line for the next shift register. So when this one records data, when the first one records data, the second one will record data at the same time automatically. And with the yellow one displaying output, that it's the same story as with the blue line. They are both hooked up to the same line, so when the first one displays its output, the second one will also display its output at the same time. Beauty about this is we can put in all 16 different bits of information and then put it out all at once. So we can make the yellow or the green and the blue one, they can go ham for a little bit, and then the yellow one can put it all out at once, and we can make distinct patterns like this, where typically a shift register will only shift information from left to right. If we make it do 16 iterations, though, we can actually shift data from the right to the left. And I've actually gone ahead here and I wrote a neat little program to oscillate a light between the left and the right, and also varying speed. So it starts off slow, it gets really fast, it goes back to being slow again. So I defined the data, the output, and the shift pins here, and I set them all to output. Pattern 1 was just something I tested out, but I went ahead and wrote 4 different functions. The 4th one was for running that first pattern, but we're not using that anymore. The update output simply sends whatever information is in the shift registers to the LEDs. Serial 1 will input a 1 or an I into the or an O into the LEDs, or into the shift register. Serial 0 will input a 0 into the shift registers. Down here I wrote an algorithm that will make it go from really fast to really slow, back to really fast, back to really slow, over and over again. And this is the result.